Okay, so we are just moving right along in our unit on chemistry. So let's move into how we can classify chemical compounds. All right, we've talked about two different types of bonding. We know that there are ionic bonds, which are between ions, metals, and nonmetals, and there are covalent or molecular compounds that are derived from covalent bonding, where the electrons are being shared. And because it's a different type of bond, they do have different types of properties. Ionic compounds are very brittle. They have very high melting points. They dissolve very easily in water, and they can conduct electricity when they are dissolved in water. On the other hand, those covalent compounds, not really brittle. They have very low melting points because their bonds are not as strong, so they melt at lower temperatures. They don't dissolve in water very easily, and they only when they dissolve in water will they conduct electricity. So that's kind of rare if they don't dissolve well. Okay, now ionic compounds form solids by building up these repeating patterns of ions. And those ions form in a very orderly three-dimensional arrangement that we call a crystal. Table salt, for instance, we know are those crystals. They are made up of sodium ions and chlorine ions. And the pattern is the same no matter what size the crystal might be. Now, molecular crystals, on the other hand, are weaker than ionic because, of course, we know those bonds, those forces that are holding them together, where they're sharing the electrons, are weaker than ionic ones. Okay. Now, we mentioned that ionic compounds have very high melting points, and so it takes a large amount of energy to separate those ions that make up the crystals. Again, because that bond, that attraction between the positive and the negative is so strong. Where molecular compounds, because the bonding is not quite as strong, the forces holding them together are weak, it doesn't take a lot of heat to separate them. So just as an example, salt has a melting point of 801 degrees. It is an ionic compound, where sugar, carbons and hydrogens, and some oxygen, covalent bonds, it's only 190 degrees. Okay, conducting electricity. We know that electricity is the flow of charges. So it really makes sense that if something is going to dissolve into water, into the ions, the positive and negative that make it up, that it's going to conduct electricity very well. And in fact, ionic crystals do that. They will dissolve in water. Those ions are free to move around, and we get good conduction of electricity. Now, molecular compounds, they don't conduct electric current because there aren't a lot of charged particles in there that make that electricity able to move. Because those molecular compounds are not breaking down into ions. Okay, now let's move into acids and bases. Acids are compounds with very specific characteristics. They react with metals and what are called carbonates. Carbonates contain carbon. Acids taste sour, and when we're talking about pH, they will turn the paper red. Bases, on the other hand, bases, on the other hand, well, they have some very specific characteristics as well. They taste bitter, they have a very slippery feel, and they will turn pH paper blue. We can see some different acids and bases in the pictures. Fruits, lemons, oranges, things with that ascorbic or that vitamin C, ascorbic acid, will have are acids. The water in your pool, which has the hydrochloric acid in it, is acidic. Bases, on the other hand, are different types of cleaners, and also milk of magnesia, something that neutralizes the acid in your stomach. Okay, so some more characteristics of acids. Again, we've talked about how acids have that sour flavor. Now, they change color when added to an indicator, and we saw this also in the acid-base web quest that you're doing. They react with metals, and they will actually produce hydrogen gas, and they conduct electric current. Now, of course, never touch or taste a concentrated solution of strong acid, which of course is why I keep all of those types of things locked up. But it's not just acids, it's bases as well. You don't want to touch or taste a concentrated base. They can be even nastier. But back to bases. They have that bitter flavor and that slippery feel. So if you've ever had your mouth washed out with soap, you know it has that bitter taste to it. They also change color when added to an indicator, and bases will conduct electric currents as well. Now, that indicator is just a compound that can change color depending on the presence of an acid or base. So whether we're using pH paper as an indicator or whether we're using cabbage juice as an indicator. Oh my goodness, and look at this wonderful way that we can display all that information on acids and bases. Hint, hint. Okay, so the strengths of acids and bases. They can be strong or they can be weak, and we have this whole scale depending on the concentration of an acid or the base. And the concentration is just the amount of acid or base that is dissolved in water. And so the strength of it really depends on the number of molecules that break apart when that acid or that base is dissolved in water. So strong acids. As the acid dissolves, the molecules break apart and produce hydrogen. If all the molecules of an acid break apart, then it's considered a strong acid. Where if it's only a small amount of the particles break apart, then it would be considered a weak acid. And here we go with bases. When all the molecules of a base break apart in water, they produce hydroxide, and it creates a strong base. If only a few molecules break apart, then it's a weak base. Okay, now what happens when acids and bases mix? Then we get a neutralization reaction. Because now those hydrogen ions that are in the acid react with the hydroxide ions that are in the base, and oh my goodness, we get water, which is neutral. Other ions from the acid and the base dissolve in the water. If the water evaporates, those ions form a salt. Holy moly. Okay, so in a neutralization reaction, what are we getting? We don't have an acid, we don't have a base, we have a pH of 7. It has been neutralized. And again, we get that salt, which is an ionic compound that forms from the positive ions on the base and the negative ions on an acid. And so salt is an example of a result of a neutralization reaction. Okay, so that pH scale I mentioned earlier. We can use an indicator, such as litmus paper or pH paper, to identify whether a solution contains an acid or a base. And all the pH scale does is describe how acidic or basic that solution is. So if it is less than 7, if the pH is less than 7, we have an acid. If it is greater than 7, we have a base. And if it is around 7, we have a neutral substance. And so take a look at some of those things that are neutral. Milk, water, your blood. Those are all things that fall in that neutral zone. Okay, so some common substances you have around your house. All that soda you insist on drinking, which is nasty, has a pH of around 2.8, 2.9. It is acidic. That's why sometimes it gives you a stomach ache, too much acid in your stomach. You can see your blood is about 7.4. And then those cleaners that we use around the house are very basic. They have pHs around 11. Caffeine is which you know I drink lots of coffee. And so I'm drinking my base, but it is a base. Now, this is interesting. Sea slugs excrete strong acids as a form of self-defense. And some other little tidbits of information. Aspirin, it's a weak acid. Glycerin, which is an amino acid that's made that helps make up proteins, is in the acid portion of the molecule. Lemons and oranges get that weak acid from citric acid. And the reason that ants, why their stings really irritate, is because it's an acid that they inject into you. Okay, well, that wraps up our brief introduction into classifying chemical compounds and, of course, talking about those acids and bases. I guess we will see you next time.